Good morning, dear students. Today we are going to talk about a lesson which causes some confusion with you. So let's start about the first lesson, which is known as the solution. What is meant by solution? Solution are two parts, which are the solute and the solvent. The solute is the part which is dissolved. The solvent is the part which carries the solute itself. So we are going to see here in this figure that you have one type of solution which is known as unsaturated solution. Why is that known as unsaturated solution? Because the number of molecules of solute is not enough concerning the solvent. As we are going to see in the next the saturated solution, which is beside it, we are going to see that the number of molecules of solute are more than the molecules of the solvent. Now we are going to see another type which shows three different types of solution, which is unsaturated solution, saturated solution, and supersaturated solution. What's the difference between the three figures? If we're going to see one of them which contains many molecules of solute, and the other one contains also many more solute, but they are starting to precip down, which means what? They are supersaturated. This means there is no space between the water molecules to carry more solute. This is known as supersaturated solution. So the first one is a saturated solution. The next one is a supersaturated solution. What is the difference between two of these solutions? That one of them, each water molecule can carry the solute, while the next one, the solute molecule starts to precip because there is no space for the solute anymore. As for the third figure, there is only unsaturated solution. Why is that unsaturated solution? Because we have solute which is not enough for the solvent, so we can put more solute. We are going to talk in the next slide about how can we form crystals from a supersaturated solution. We bring a string and then we put it some crystals and then we put it in a supersaturated solution. This string, by rotating it will take the solute which has saturated the solution and forms it on it. So it will form crystals of the solute which has supersaturated solution with water. Now in the next slide, we're going to see the relation between solubility and temperature. What is meant by solubility? The solubility is the degree of dissolving of a solute in a certain amount of water. So what does it depends on? It depends on the degree of the solubility of the solute, and it depends on the temperature. In this figure, we can see many types of solute which has different properties with the temperature. Some solutes increase solubility with increase in temperature. Some solute doesn't change, and some solute, the dissolving process decrease by the increase in temperature. The next slide, we're going to see what is meant by the dissolving of NaCl in water. NaCl is considered an ionic compound. What is meant by ionic compound? Ionic compound is a substance that contains a complete positive ion and a complete negative ion. So what happens when it dissolves in water? The positive ion is attracted to the negative ion of water. Water is considered a covalent compound, yet it is considered have a polar substance. Why is it a polar substance? Because the oxygen in water has high electronegativity, so it attracts the shared electrons to its nucleus more, leaving the hydrogen with positive charge, and so the oxygen will carry partial negative charge. So there will be a bond formed between the positive of the ionic compound and the negative of the water, and vice versa, the negative of the ionic compound with the positive of the water or the solvent in water. Now we are going to see the colligative properties of solution. There are three types of colligative properties, which are the vapor pressure and the freezing point and the boiling point. We are going to see now first one, which is the vapor pressure. Let's talk about what is meant by vapor pressure. In any container, if we have a solution and we have only a solvent, solution means what? A solute and solvent. So there is a bond formed between what? The solute and the solvent. As for the beaker that contains only solvent, there is a bond between only solvent molecules. So which one will form a vapor pressure higher than the other? The one which has space to move easily and the bonds which are not that strong makes it to collide with the walls of the container, forming vapor pressure. So if we're going to see in this part, we will see that the pure water has more vapor pressure than the solution. Why is that? Because only the bond is formed between water molecules. So by breaking the bonds in water molecules, it gives space for the molecules to collide with the walls of the container, forming what? Vapor pressure. As for the solution, it takes a longer time. Why does it take a longer time? Because to separate between a solute and solvent takes a longer time. And then after that, it starts to collide with the walls of the container, forming vapor pressure which is less than the pure solvent. In the next slide, there's an example of a closed container or closed system. Why is that? Because it shows which one has a vapor pressure more than the other. If we're going to talk about only solvent, which is the bond formed between only water molecules. But as for solution, it is the bond formed between solute and solvent. Which one is easier to separate between them? The solvent molecules only or the solute and the solvent? Of course, to separate between the solvent molecules only, it takes a better, or it's much easier than between a solute and solution. So that means that the surface molecules starts to collide with the walls of the container. When they collide with the wall container, they form a vapor pressure. So if we're going to compare, the vapor pressure of solvent is higher than the vapor pressure of a solution. This takes place until equilibrium. What is meant by equilibrium? That the pressure in both sides are equal. So this process will stop. In the next slide, we are going to talk about why is the vapor pressure lowered in solution. Because the bond between the solute and the solvent is very strong. So it will take higher temperature to separate between these two molecules. After we separate between these two molecules, this starts to collide with the walls of the container, forming vapor pressure. It will take a longer time than if we're going to talk about a pure solvent. Pure solvent is only a hydrogen bond which is formed between water molecules only. So it is much easier to separate between the molecules of water, especially in the surface molecules. It's much easier, so they will collide and it form vapor pressure easier than a solution. Now we're going to talk about the boiling point. What is the boiling point of water? The boiling point of water is 100 centigrade. What is meant by the boiling point of water is 100 centigrade? This means that the water molecules start to move, forming kinetic energy, and so it will change from liquid to vapor. This is the boiling point of water. So if we're going to compare between boiling point of water and boiling point of solution, boiling point of water, as we said before, it is 100 centigrade. This means what? At 100 centigrade, the water starts to change from liquid to vapor. But if we're going to talk about the boiling point of a solution, for example, if we're going to talk about solvent and solute and NaCl, it will take a higher temperature. Why is that? Due to the strong bond which is formed between the solute and the solvent. So to separate between these strong bonds, it takes a higher temperature. So therefore, the boiling point of water is 100 centigrade, and if you're going to talk about the boiling point of water and, for example, salt, it is 110 centigrade. And why is that? Because it takes a higher temperature to separate between what? The molecules of the solute and the solvent. Next, we're going to talk about the colligative properties of electrolytes. What is meant by electrolytes? Electrolytes are substances that gives ions, positive ion and negative ion. So if we have a positive ion and negative ion, therefore it will form a strong bond with water, where the positive ion will form a bond with the negative ion or negative part of the water, and the negative ion will form a bond with the positive part of the what? Of the water. Therefore it will form a stronger bond than the hydrogen bond. Now we're going to see another type of a colligative property which causes a type of confusion with you. It is the freezing point. What is the freezing point of water? Freezing point of water is 0 centigrade. What is meant by the freezing point of water is 0 centigrade. This means that at 0 centigrade, the water molecules changes from liquid to solid. This happens when the temperature reaches 0 centigrade. In cold countries, this is a big problem. Why is that? Because cold countries, the temperature can reach minus and below 0 centigrade. So this means what? All the living organisms, especially that live in water, cannot survive. So what happened due to that? The upper surface of the water at 0 centigrade forms ice. And ice acts as an isolating layer. It isolates the outer temperature from the inner temperature. Therefore, it leaves the temperature downwards constant at 4 centigrade. This temperature, 4 centigrade, is suitable for living organisms. As if we're going to talk about the rods in the cold countries, it is a big problem that if there is water, it will change to ice because the temperature reaches below 0. Therefore, what will happen? There will happen a skidding and accidents between cars. Why is that? Because the ice makes the cars to slide. Therefore, it will happen, it will cause problems. So how can we solve this problem? In cold countries, they put on the water NaCl or any type of salt. Why is that? Because it decreases the freezing point. And why does it decrease the freezing point? Because water and the solute form bonds. So if we want to freeze this water, it will take a much lower temperature to freeze. But in water, it freezes at 0 centigrade. But in solution, it freezes at below 0 centigrade. So in cold countries, they add salts to the water in the streets. Why? To decrease the freezing point of the water. Instead of being freezing at 0 centigrade, it can freeze at -4 centigrade. So it will prevent accidents that take place by cars in the road. So if we're going to talk about the last slide here, it shows the freezing point depression. If we increase the number of solute in the solvent, therefore it will decrease what? It will decrease the freezing point. So if we're going to compare, for example, NaCl in water and sodium carbonate in water, which one has the least freezing point? Of course, sodium carbonate in water. And why is that? Because NaCl is made of 2 moles only. So 2 moles only form bonds with water. But sodium carbonate are 3 moles. 3 moles form a bond. So it will take much longer time for these to separate between the molecules and to become the water molecules closer to each other to form ice. So the freezing point of water is 0 centigrade, while that of solution will be below that. And if we're going to talk about NaCl in water, therefore it will take, a lower temperature. But if we're going to talk about sodium carbonate in water, it will take a much lower temperature to freeze. And why is that? Because the number of moles in sodium carbonate is higher than that of NaCl. I hope you have understood this lesson and hope you good luck always. Thank you very much.